Now let's look at it, how it works across a whole APU or a whole heterogeneous platform. Here we have GPUs and CPUs working together. Multiple queues feeding each of the processing units, and each processing unit can feed each of the other queues. The application starts up and starts feeding work to the CPU queues in this task parallel runtime, and the CPUs execute those tasks and maybe are feeding back work into CPU queues. Then it starts to get interesting. The application continues to feed work into the CPU queues, work comes back around, but now the GPU can get involved as well. Work starts flowing from the application or the runtime to the GPU. Work can flow from a CPU task that can queue directly to the GPU. The GPU can queue to itself. This is really important for doing algorithms like recursion or scene graphs. And of course, the GPU needs to call out to the CPU when it needs syscalls for system services, or if the task running on the GPU has just created work that is scalar in nature and should run where it will run at the most efficiency. Here you don't see grey plastic trays. You don't see queues that stop and start. This is a thing of beauty. So where are we taking you? The overriding message is we want to switch the compute, not move the data. In an APU with system memory, it makes no sense to copy the data from one section of the same memory to another for different processes to operate on it. All the processors are capable. You choose the processor now by its performance characteristics and execute on the data in place. This system has easy support for massive data sets, whether you're crunching all the data at once or whether you have sparse access to a large data set, whether you have massive data parallelism or nested or braided data parallelism. First-class support for task parallel systems, solutions for all platforms, all the way from high-performance computing down through tablets and beyond. And it's open to all. This is the future of heterogeneous computing. The architectural path forward is clear. We take established programming patterns, symmetric multiprocessing coherency, task parallel runtimes, we extend them to the whole platform. It's an open architecture with published specifications and an open source execution stack. We have heterogeneous cores working together seamlessly in coherent memory, low latency dispatch, and most important of all to software developers, no software fault lines. The investment you make today on the heterogeneous platform will pay off today and get faster and better in the future. I thank you for your attention. I hope you have a great conference. You've seen the future. You saw it from AMD first. Thank you.